Hello everyone, welcome back to my video series. This is Joy, and today we are going to establish iBGP between our DC and DR. Previously, we have established the eBGP from port 1 and port 2 from DC, and same for DR, port 1 and port 2. The BGP is up and we are receiving the default route from the ISP. In this video, we'll establish the iBGP and we'll try to ping from our DC web to DR web. That's the goal. So I will publish these 4 networks from DC so our DR can receive it, and from DR I will publish these 4 networks so DC will receive that. And to do that, I will up this port 3 link and we'll put a point-to-point IP 10.100.1.1 in here and .2 in there and establish the iBGP over there. So let's do it. It's actually very simple, like eBGP and iBGP is mostly same. Configuration is mostly same, but internal traffic distribution, advertising are totally different. So to do that, we actually, let's see from the CLI, get router info BGP summary. See, we have now only 2 BGPs, received one prefix. Let's also establish the BGP now. So to do that, first we need to put the IP in the interface, port 3, simple, manual 10.100.1/24. I took a random IP just out of my network, so just use that one, nothing special. Okay, IP is there, so let's create the BGP. Create new. So what will be our remote IP? So a remote IP is the remote firewall connected IP address. So that would be 10.100.101.2. Remote ASN is actually the same ASN, 65253. Nothing much. Soft reconfiguration enabled. Sorry. Yeah, done. Apply. The iBGP configuration is done, but still we didn't advertise any network from there. So let's establish the network, then we will apply the advertisement. So now I'm going to my DR. Network. Oh, sorry, first I need to configure the port. 10.100.101.2/24. Okay, then BGP, create new 172, oh sorry, 10.100.101.1. That's our DC IP. So in the DR, the neighbor is DC and the neighbor IP is this. Neighbor ASN number 253, oops, 65253. Done. Soft reconfiguration. I haven't shown you anything why I enable the soft reconfiguration, but I'll show you. Okay. Apply. Back. Done. Nothing more. See? We can also, from GUI, we can see the BGP neighbors. All three neighbors are up. And from here, if you want to see the BGP path, you can also see that. So far, we haven't received any DCIP from tier. So how can we do that? So now I'm in my DC. In the DC, here you can see the network. So whatever you want to advertise your neighbor, you need to put that IP in here. And the most important thing in BGP that without the address in your route table, you cannot advertise that IP. Like whatever IP you have in your route table, you can only advertise that or only block that one. So let's see what is in our route table. Get router info BGP. No. Routing table all. See, these are my routing table. In my routing table, I have 10.0.0.0/24. So I can advertise that one to my neighbor. But if I put 10.0.1.0/24, so it will not advertise to the remote one. Let's verify this. So 10.0.0.0/24. Also for the test purpose 10.0.0.10/24. So this should not be advertised from DC to DR, but this should be. Let's see if it's reachable advertising or not. Let's go to the CLI, or let's do it from here. So from DR, actually we need to see it from DR. Get router info BGP summary. See, previously there was no advertisement or prefix in there. Now we receive one. So what is the routes actually we are receiving? Sorry, from here we are seeing two. Why two? Let's see what prefix we are receiving. So, but we only published one network, but it's receiving two. Let's see what are the prefixes we are receiving right now. Get router info BGP neighbor IP, and what routes we are receiving. See, we are receiving the 10.0.0.0/24 and also the default route. Why we are receiving? And see the next hop. The next hop is our ISP IP. So how it become? Let's explain that one. So 10.0.0.0/24, we have no issue with that because I am advertising that from this one, so it's receiving that one. But how come the 00 come? So the 00, we actually push it from there, and the 000 is in BGP DC firewall routing table. And when it actually we up the BGP, so when it's in the BGP routing table, it's also advertised from here to here. But we don't want to do that, so later on we'll fix that. Like, even though it's receiving it from here, but it will not advertise from the DC to DR. We'll do that. So yeah, because I want to show you the mess and then the cleanup, so it's a bit understandable for my perspective that if you see the mess, it's easy to clean up. Like, I can clean up from beginning. At that point you will see nothing, like no default route receiving from the DC. Yeah, so let's also publish the other one, and then in the next video we'll see the prefix lists to clean up that one. So our others are 8, our DB 16, and common are 24. Done. Now we will see that we will receive other 2. Yeah, other 4 we also receiving from our DC. Don't think about the default route. We will cut over that one in our next video. So this is called the route manipulation or traffic tuning. So in the next video that will be more interesting. Yeah, from the DC, get router info, BGP summary. See, from the DR we are receiving one route. So let's see what's the route we are receiving. Get router info, BGP neighbor. Routes. See, we are receiving the default route from 172.16.254.2. So what is happening? It's the ISP1 originated the default route. ISP1 originated the default route to the DR firewall, and the DR firewall actually forwarding the default route to the DC route again. So it's a total mess, right? So we'll fix that, and we will always make this link as a primary and this link as a secondary. Same for this. This is primary, this is secondary, and we'll block the 000 advertisement from DC to DR and DR to DC. And yeah, let's back to the BGP. So we need to put 10.1.0.0/24. I think you can understand, like, where I'm getting this IP. I'm actually getting this IP from my IP sheet. See the DR app. So web is 10, app is 18, DB is 116, and common is 124, the DR. Eight, 16, 24. Now our DC will receive all the routes. Routes up there. So whatever you think, can I ping my DC web to DR web? I go to the topology. This is our DR web. And this is our DC web. Let's do a ping. ipconfig, sorry, ipconfig, yep, 10.0.0.1 up to DC we can reach. Now let's see, we can reach to our DR. No, let's see the DR web. It's have the correct IP or not. Okay, so in our DR we haven't established the DHCP, so let's do a manual. Okay, networking, Ethernet, change adapter options, properties, 10, 1, 0, 100, 255, 255, 2550, 10, 1, 0, 1, then 10, 1, 24, 100. Okay, close, ping 10, 1, 0, 1. Haven't I created all the VLANs in the DR? Let's do the troubleshoot. In the DR, yes, we have created 10101 and the VLAN. Do you know how to see the VLAN? So for the VLAN, you need to go right click on this bar and VLAN ID. Select the VLAN ID. Yeah, this your VLAN is 100. Whatever I think I haven't configured the switch yet. So let's do the switch configuration. Enable show VLAN. Yeah, see, there is no VLAN. Config terminal, VLAN 100, 200, 300, 400, interface gig 0 by 0, switchboard trunk encapsulation .1q, switchboard mode trunk, interface gig 0 by 1, switchboard mode access, switchboard access VLAN. What? 100. Let's configure the others also. Two hundred. 300. Sorry, 0 by 3. 1 by 0. 400. Do right. Yeah. Switch configuration done. Now in my DR, I should reach to the gateway. Yep, gateway is reachable. Yeah. But still, from my DC, I don't have the communication. Why is that? Because now we have the routing, but we don't apply the policies. let's apply the policies. So in the router, is routing is enabled. We have the route, it's reachable, it got the reachability. But in the firewall, with the route table, you also need the policies. Admin policy. Where is policy? Policy create DC web to DR web. So I put a name that I can easily understand. That's incoming interface will be made by DC app. Outgoing interface will be my port 3 because it's coming from this interface and it's going to my this port 3 to the DR. Source will be my DC web. Destination will be mine. Okay, I haven't created the DR web. Let's create it. Address DR web 0 underscore 10.1.0.0/24. Okay, I cannot put slash over there. Underscore, yeah. Tier services. Let's be resi all, and it will be not netted. Okay. Service all is not clear. Yeah. Yes, so my DC to DR, it's now we have the policies. Let's see. So in the log, let's see the logs. Yeah, from previous like 0, 100, from my DC DR ping was denied. Now let's see, we should have allowed it. Because in the default deny policy, it was blocked. Okay, there might be session establishment. So let's do re-establish the session. Still waiting for my logs. We should see that that is allowing. Policy, have I created the right policy? Let's see. I don't like this, I like this one. DC web to DCDB, DC web to port 3. Yep, it is right. 10.0.0.0/24.10. But still it's not hitting. Why it's not hitting? Get router info BGP summary. Get router info BGP neighbors. Yeah, routes are there and those are valid also. Get router info routing table all. Yeah, using the BGP, I'm receiving that one. Why it's not hitting any packets? DC wave. Oh, see, I select the wrong interface. So that's why there is no traffic heated. Okay, let's change it. Yippee. See, immediate change, there are some traffic hits. Okay, see the hit count, it's 1. So in my log, I should see that's now allowed. Yeah, let's refresh that. Still the old logs minutes ago, the new logs it takes some time. Let's reinitiate it. Yeah, see, still it's not reachable. Because you know why? Because we allowed policy in here. So now from here up to there, it can go up to the tier. But in here, there is no policy. So whenever it comes, it will block. So I really want to show you. Sometimes it's very late. Let's wait for some time. I know it's going to be a big video, but let's just hope for the best. Policy, firewall policy. Show matching logs. Why? Oh, I know why. In the policy, firewall policy, I think I haven't enabled the logs. Yeah, the logs are enabled. Why it's not showing? Okay, generate station, capture packets, everything I opened. Let's turn off the capture packet. I'll show you the capture packet on some next video. Let's see. Now I can see the logs or not. Yes, the logs are coming. Yeah, these are the 24. At source, let's specify source. Source is our 10.0.100. See, there is, let's also add the destination. Destination 10.0.100. Yeah. See, previously it was blocked. Now it's accepted, allowed. But still, our communication is not established. Communication is still denied. So let's create a policy in the DR also, so we can see the policies. Step policies, firewall address, create DR web. Actually, it will come from DC web, accepting by DR web. So hereby I can understand it's initiated by DC web and the receiver is the DR web. It will come from port 3. It will go to DC web. So from the topology, if you can see, the packet initiated from here come to port 4. So the DC web is our source for the DC firewall and the destination was port 3. Now from you are in here, you can see that if you see now, the packet is coming to port 3 and going to the DC web. DC web source will be our, okay, I haven't created any, just let's do the all. Later on we'll do the more specific. Actually, I'm showing you how to do it accurately in the DC and just to be lazy in the DR. Service all, I don't want that. Okay. See, immediately the ping is up. That's the beauty. Okay, so our DC and DR communication is okay. Yeah, and I showed you how to do the iBGPs, but I have created a mess. In the next video, I'll show you the mess. I have already shown you a little bit mess, like we are receiving the default route and send it to the DR, but we also send our internal traffic to our ISPs also. Just a little bit, showing you a little bit. Get router info BGP summary, get router info BGP neighbor. So this is our ISP1 neighbor, and in here we can also see that what routes we are advertising. Like previously we showed that from the BGP, from here what we are receiving, and now we'll see that from this router what we are advertising. So for this one, this is the command advertise route. See, we are sending a lots of route, like our DC internal IP, our DR internal IP, because all of them are in our routing table. So we are sending it to the ISP, which we don't want to do. And 53, and for the secondary, this is also some. See, we are receiving the default route from the ISP1. As because we are receiving the default routing from ISP1, we are not sending it to the ISP1 because the default route is valid for ISP1. How do I see that? I'll show you. Okay. In the ISP2, we are also sharing the default route. So we need some access control to control this. In the next video, I'll create the prefix lists. And how do I know that the ISP1 default route is valid? With a simple command, get router info BGP network 0000. See, we are receiving multiple of default route from various neighbor. This is from the ISP1. We are receiving another from ISP1, but that one is originate to another IP, and this is from the ISP1 also. So, and this is actually the valid one, so there are multiple default route we are receiving. So why multiple is there? Actually 3 multiple is there, because what I did for my ISP, I pre-established a BGP from here to here, and this one also generate a default route to ISP1. When it's received, then it's also originate one and also pass its default route. But we will segregate those things, like will not receive those things. Yeah, like only these two will receive. So now it's a messy environment. Next time we'll clear it. See you in next video. Thank you.